Okay, here's my code. It is a big conglomerate of just kind of organized code. It kind of goes in succession with the PowerPoint and the list of requirements in the assignment itself. So the language I chose is Julia, and I'll run it here. And it's very similar to Python. It is strongly typed and dynamically typed, and it's very good with statistical work and math, particularly with ASCII symbols as well as UTF-8 encoding, which means it can have emojis. To begin, we have our hello message, hello world, right, and we just print it out, basic print statement. And then we also have a greet function. This is basically, hello world, just place the name in there, but just like that. And then you have to prefix it with the $. And of course you just, like Python, name this. You don't have to distinct it with a string, and you can just plug it in. So this is just like a new line feature essentially. Notice this symbol. That's very nice, one of the features of Julia. And we also, so let's say our function pi is good, right? This is just basically comparing if this actual digit pi is equal to 3.14 when we round it, right? Because I don't know pi beyond 2 digits. I'm not a mathematician. But this returns true. Is pi equal to 3.14 true? So that's nice. That's awesome. And then our next line, can we add two different types? 1 plus pi. Oh, we can add two different pi types. Okay. Sorry, I worded that a little weirdly, but I was just showing that we can add it like this. And then there's also a specific syntax, which is equivalent to plus in parentheses 1 comma 2. And this is just, the same as 1 plus 2. And here's our a function where we can add things together, right? The sigma function. And then I kind of extrapolated it to this call sigma function where we have this array, just 1 through 5, and a sum of 0, and then we iterate it, right, for each item in array. We have this sum, which is, we call the function, and that's the sum of the item, right? So it updates the sum each iteration. So when you're going through an array, you have to, in Julia, you have to enumerate it first, right, to go through it. Or that's one of the ways you can go through it. And in this instance, you are returned a tuple, a pair of like a key value. And so you see, I just work with the value here and just, work with the iterator, just leave it in the background. So essentially we call this function a bunch of times, boom, 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 and it works like, the sum of 1 to n. New line. This is just a big conglomerate of just, mathematical works that you can do, just pushing the limits of what there is and kind of what if statements work, or how if statements work. And it's all very predictable. We just, get some elements going and then some Boolean values. And we have this just, random function, you can multiply, you can take to the power, this is square root in this instance, you can plus equals. But there is no minus minus or plus plus in Julia like there is in Python. And there actually is no delta equivalent signal, right? Or like similar kind of syntax, and the and specifically requires Boolean value, which you can use to, if statements and whatnot. And each loop, whether it be a for loop, while loop, if loop, is going to require these end statements, right? Yeah, sorry, I'm trying to make sure I include everything I wrote in the comments, but it's kind of hard when you're recording a video. So yeah, we just print out this function and see what comes out, which is the works 93.42. And then this is also the sum of the array. So, I won't keep going on too much, but we have this sample statement chef is super cool. And we can take a couple of, like type of, essentially is a function that will return like type of the sample, it's a string, right? Type of the units, right? It's a UTF-8 byte. It just keeps going on, and then code needed sample 1 is specifically J, which is ASCII code for 74, and so you can do char 74 and you can actually return it, right? So here you see 74 for 1. Oh, it's also, Julia does not do 0 indexing, it's 1 indexing, which is a little confusing, but it's whatever. Anyway, 1 is J, correlates to J, and then char 74 is J. So I was just showing that kind of loop. Here is another thing of working with strings. Essentially, IO buffer is used for efficient string concatenation. It's basically, it uses buffer to store the strings that come in until it is full, then it writes to memory. Because the issue with string concatenation is that they're immutable, right? So if you're doing a lot of tight loops with strings, quick successions, adding just 1 or 2 chars every few milliseconds, this is very inefficient, not only time wise but memory wise, right? We're allocating new memory each time. So this is just a more efficient means of handling it, right? It's still a little bit of voodoo magic to me, but this is the syntax for it. And note, in Julia 2, you'll often have this statement where it's like some command exclamation point object. In sets, it's like push exclamation point the value you want to push to the set itself. We'll go over that later in a second here. So here's just a couple of data structure stuff. It's all written in comments, so I'm gonna stop because this video is getting a little long at 7 minutes. But yeah, we have arrays, we have dictionaries. A really cool aspect of sets is that if you ask is mutable inventory, where inventory is a set, it says it is false, which means the sets are immutable, right? Is this type mutable? It's not. And if you can actually like push right into this set another item, and it still works. It's the same ID both before and after the set itself, yet it's mutable, right? Despite it saying immutable. And this is an interesting feature of Julia. It's where the set is actually a wrapper function of dictionary. So I think it's the wrapper itself, or some aspect of it is immutable itself. It's just that the values itself are modifiable through some weird complex means of source code, which I do not really want to dive into. And here's a couple examples of structs, very similar to Python, except you can actually make them, you can designate it as mutable specifically. And here's a couple examples of just calling them. You have dog and person. And then Julia itself doesn't have any classes, but it does have a thing called multiple dispatch, or you can just overload functions. Like here we have a generic greet function, xy, it doesn't matter what passed in here. But we can also have one that's designated by strings, specifically Alex and James, right? And one that's specifically int. So yeah, that is that.